connecting solar panels in parallel connection of same rating as well as different rating. So here a question is given to us, what will be the total current and what will be the maximum power rating of the solar panel if they are connected in parallel. Okay, so what are the ratings given to the solar panel? Maximum voltage is how much? 12 volts. Maximum current is how much? 2 amps. Okay, so how to connect the solar panel? What is the symbol of a solar panel? So you will have a solar panel like this, and inside you have to draw like this. Okay, so you are going to have a solar panel, a box like this, and inside you have to draw like this, and you are going to get one terminal like this and another terminal like this. So in this connection you can observe that one terminal will act as an positive terminal and this terminal will act as an positive terminal. Okay, so the next terminal will be negative. So now how to connect them in parallel? How to is asked that you calculate the total current and the maximum power when they are connected in parallel connection. Okay, and calculate the maximum power. Okay, how to connect them in parallel? Join all the positives. Okay, so here I am joining the positives of the solar panel, and here I am joining all the negatives of the solar panel. Okay, when you join all the positives and all the negative, one terminal will act as a positive terminal and one terminal will act as an which terminal? Negative terminal. So what is the rating given for the solar panel? So Vm is equal to how much? 12 volts, and current Im is equal to how much? 2 amperes. What is the output voltage of this panel? 12 volts. Therefore what is the voltage at this point? 12 volts. How much? 0 volts. And what is this panel given? This is solar PV panel 1, this is solar PV panel 2. What is the voltage rating of this panel? 12 volts. Okay, so here 12 means how much? Here also you are going to get 12 volts, and here is how much? 0 volts. Okay, and what is the current developed by this panel given as per the problem? So here in this branch, how much amount of current is flowing? Im is equal to how many amperes? 2 amperes. Here Im is equal to how many amperes? 2 amperes. But I want to find out the resultant current. Okay, so the resultant current is flowing like this. I want to find out the current Ix. Okay, two currents are known, one current is unknown. So I am going to apply in order to find the unknown current, which method we can use? Apply Kirchhoff's current law. So apply Kirchhoff's current law at this node. Okay, at the node V. So when you apply it, identify how many entering currents are there, how many leaving currents are there. How many entering currents are there? So the entering currents are Im plus Im. Okay, what is the leaving current? Ix. So I can write down this Im as 2 into Im is nothing but which current? Ix. Okay, so this is the 2 Im is the current. Okay, where this Ix is also called as the maximum current of the array. Maximum current of the array. So the maximum current this array will develop is called as the maximum current of the array. Now what is the maximum voltage of the array? What is the maximum voltage of the array? So this is 12 volts, 12 volts. Automatically these two are connected in parallel. So in a parallel connection the voltage is same. So therefore here how much you are going to get? 12 volts, and here you are going to get 0 volts. And what is the current you are going to get? IMA, where IMA is equal to how many times? So this is nothing but 2 times I maximum value. Okay, so this is standard. So in the same problem only I am explaining the parallel combination and solving the problem. Okay, so therefore you got, so therefore what is the maximum power you are going to get? The maximum power generated by the array is equal to, it's a product of maximum voltage of the array multiplied with the maximum current of the array. Okay, so what is the maximum voltage of the array? Vma is equal to how much? 12 volts. The 12 volts is called as how much? Vm. Yes or no? Vm is how much? 12 volts. Okay, the maximum voltage of the array is how much? V into m. What is the maximum current of the array as per the problem? 2 into Im. So here you are going to get 2 into Im. So this I can simplify it as 2 into Vm into Im. So this I can write down it as 2 into Pm. So the maximum power of the array when they are connected in which connection? Parallel connection. The power is increased how many times? 2 times. If we use 2 number of solar panel in which connection? Parallel connection, the power is increased how many times? 2 times. If we use 3 number of solar panel, how many number of solar panel? 3 number of solar panel, the power is increased how many times? 3 times. If we use 4 number of solar panel, the power is increased how many times? 4 times P maximum. That's what the importance. But coming to our problem, this is what generally how to connect the solar panels in which connection? Parallel connection. So but in this numerical, what is given to us? So he is asking us calculate the total current. So what is the total current of the array? So the maximum voltage of the array, what is the formula? 2 into Im. So what is the Im as per given in the problem? Im is how much? 2. So 2 into 2, this is equal how many amperes? 4 amperes is the total current when these two solar panels are connected in parallel connection, and is asking us to calculate maximum power. Okay, so what is the formula for P maximum when two are connected in parallel? 2 into Pm is nothing but 2 into Pm. So what is 2 into Pm? 12 into 2 amperes. Actually this is a product. Why? Because current is increased how many times? 2 times, and voltage remains same. What is this value? How much? 48 watts, and this value will be the peak. Now you understand. So now what is our resultant? When you connect two solar panel of rating 2 volts and 2 amperes, the resultant current is how much? 4 amperes. Why it is 4 ampere? Here 2 amperes is current is coming, here 2 amperes current is coming. Resultant, how much amount of current is available in the array? 4 amperes. How much voltage is available? 12 volts, 12 volts and 12 volts. 12 into 4. How we got the 4? 2 ampere current of the panel multiplied with how many times? They are connected in parallel into 2 times. Therefore, what is the total power of the array? 48 watt peak. This is how to solve the problem when two solar panels of same rated are connected in. What is the type of connection? They are connected in parallel. This is the current value. So this is the current value and this is the power value.